Okay, in number 25, we have lines in a plane, and we have this relation which we're going to define as is perpendicular to. And we have three particular types of operators there, or we have three particular types of relationships: reflexive, symmetric, and transitive. So for the first one, let's talk about reflexive. Something is reflexive if it equals itself. A equals A is reflexive. In this case, you would say that A, or line 1, is perpendicular to line 1. It would have to be the same thing on both sides. But a line can never be perpendicular to itself, and so A cannot be true. Uh, it cannot be reflexive. And so answer A is out. A line cannot be perpendicular to itself. In order to be reflexive, it has to be that way. So that's the definition of reflexive. Line 1 would have to be perpendicular to line 1, which is not possible. All right, something is symmetric. When something is symmetric, we say if line 1 is perpendicular to line 2, then we should be able to flip it around and say line 2 is perpendicular to line 1. And that is true. All right, transitive. Transitive basically means that if line 1 is perpendicular to line 2, and if line 2 is perpendicular to line 3, then line 1 is perpendicular to line 3. Alright, so let's think about that particular one. Is this, do we have the transitive, does the transitive property apply? So let's look at line 1. Here's a line. Now here's a line that's perpendicular to that. So line 1 is perpendicular to line 2. Now line 2 is perpendicular to line 3. So in order to be perpendicular to line 2, then line 3 really has to be parallel to line 1. So does this hold true? If line 1 is perpendicular to line 2 and line 2 is perpendicular to line 3, then is line 1 perpendicular to line 3? No, line 1 is parallel to line 3. So from these three different properties, we see that the reflexive property does not apply because a line cannot be perpendicular to itself. But if the symmetric property is true, because if a line is perpendicular to another line, then that other line is also perpendicular to the first line. So that's true. But it's not transitive because if one line is perpendicular to the second is perpendicular to the third, then the first and the third are not perpendicular. They are parallel. So we know that it is symmetric but not transitive. So the answer has to be B. It is not transitive, so C is not correct. Both symmetric and transitive is not correct. Once again, reflexive is false, symmetric is true, and transitive is false. So from these we can tell which answers are valid and which are not. So these properties, again, I doubt that you will see a question that asks about lines being perpendicular, but reflexive is something that you would need to know about. In just algebraic terms, we would say something is reflexive if it equals itself. So x equals x is a reflexive property there. Symmetric means that x plus y is equal to y plus x, or x times y is equal to y times x. That's very similar to what we call commutativity. For the transitive, if x equals y and y equals z, then x equals z. So when we talk about equality as the relation, then equality is transitive and it is symmetric. And you can say x equals x is going to be reflexive. However, and this is perpendicular to relation, only the second symmetric applies.